Activity 4.4 also gets into the idea of transformations of our exponential curves. However, in my opinion, exploring those transformations with Desmos can be a little bit more intuitive and practical as we can visualize those changes. So let's take a look at what I'm talking about here. So we could start off with the graph of a general exponential equation. So y equals a to the x. Since we put in a constant for a instead of a number, we'll be asked if we want to add a slider. So we go ahead and do that, and now we actually see our graph being graphed, our equation being graphed. What we start off with is actually a horizontal line. So an initial question that you could ask here is, why are we seeing a horizontal line instead of something that we would more expect to see as that exponential curve shape? In this case, since what we're evaluating is just 1 to whatever power, really all we have is just the equation y equals 1. From there, students can manipulate the slider, and you could have them start to describe and explain how the graph changes as the base of that exponential function changes. So for instance, we can slide that value to become larger, and we see that our horizontal line turns into an increasing exponential function as a gets larger than 1, and then as a gets less than 1, we start to see a decreasing exponential curve. We could add to that, or create a separate equation just to see. We could add to this by, instead of just having a to the x, we could have y equals a to the x plus b plus c, which would then allow us to add sliders to those remaining constants, and we could start to see what happens as we change each of these values. So I'll go ahead and change a so that we have an increasing exponential function. Hopefully students have already mastered that concept before you move on. And then we can start to see how our graph changes as our value for b changes. So as it changes what we're adding or subtracting to our original exponent, and then what we're adding or subtracting to the original function. We can see that as we change our value for b, we get a horizontal shift in our curve. As we change our value for c, we get a vertical shift in our curve. So you can have students start to experiment with those different transformations, and rather than, again, in my opinion, drawing functions repeatedly over and over again and maybe not necessarily getting those connections, getting to see some instant dynamic feedback on what happens as we change each of those different values. So if time allows in the class, this is just an additional activity that you could have you could engage in to have students explore exponential functions a little bit more deeply.